I'll share the. Okay. So I have shared my whiteboard. Right. So yesterday we were talking about indices and we discussed some rules, like all the rules and some examples. Okay. So today we will solve some simultaneous equations which are related to the same topic. And basically it is a past paper question. So I have question number 1 for today that is related to the topic indices. So let's say you have 32x multiplied by 2y equals 1. This is your first simultaneous equation. And the second one is 3 to the power x minus 12 divided by 27y equals 81 to the power 1 by 2. Now, apparently, it looks like the world's most difficult question that we would not be able to solve, but it's not like that, okay? We have two simultaneous equations and the variable is in power. So forget about simultaneous equations. Let's solve 1 and 2 separately. Let's try bringing the variable from power to base, and then we would be able to talk about it. Okay, so how do we do these questions? Okay, now I want to write down, I'm on I'm on the first equation. I want to have an equation such that the base is same. Okay, so can I write 32 in terms of 2? Yes, 2 to the power 5 is 32. Okay, so 2 to the power 5 x multiplied by 2 power y. Can I write 1 with base 2 somehow? Hmm.
Yes, the power will be in fractions then.
Okay, basically the power will be 0. Okay, we know that any number to the power 0 is 1. Okay,
Okay.
this was a rule. Okay, all right, now let's just simplify this. I can multiply 5 and x, that was also a rule, multiplied by 2y equals 2 to the power 0. Now I have same bases. When bases are same and they're being multiplied, I can sum the powers and this would be the thing. And finally, I have same bases. Both these things are equal. This means that their powers must be equal. Okay, so 5xy equals 0. Now things are much easy for me. Now I can think about this as my first simultaneous equation, and we'll solve the simultaneous equations later. But let's talk about this equation right here. Now again, this looks very complicated, but trust me, it's not. Okay, let's just try writing things in a much better way. So basically we have x minus 12 as the power of 3. That's okay if we have it with a variable and a number, that's completely fine. All you need to understand is that it's the power, that's it. So it is x minus 2. Okay, now I can write it as 3 to the power x minus 12. Basically it's not x minus 2, it is x minus 12 divided by. Now I want to have same base everywhere. So what is the smallest number? The smallest number is 3 basically, right? So I can write 27 with the base of 3. I can write 81 with the base of 3. So 27 can be written as 3 to the power what? 3 to the power 3.
Three.
Very good. And we have 27 power y equals and 81. Now this, if you think about 81 directly, it would be very complicated, but we know that 9 into 9 is 81, right? Because like 9 square is 81. So I can say that 3 square into 3 square is 81, and bases are same, powers can be added. So 3 to the power 4 is 81, right? 3 to the power 4 is 81. And I can write 1 by 2 outside the brackets. Finally, I have 3x minus 12 divided by 3. 3 and y can be multiplied equals 3 to the power. What are we going to have? Okay, yes, this is basically x. Okay, this is x. This is not 2. This is x. We have not used it anywhere. So everything is correct. This is x. This is also x. So I need to rewrite it as x, 1 by x and 1 by x. Okay, so we have 4 by x. Okay, now we can use the rule. We have same bases and we have the division sign. So I can write it with 1 base, x minus 12 minus 3y. Okay, so basically this is the first power, this is the second power. I'm subtracting them because I have the division sign, equals 3 to the power 4 by x. Now I know that my bases are same and these two numbers are equal. This means that their powers must be same as well. So this is 4 by x. Now finally, I have two equations with two variables, and the variables are not in the power. They are basically as the base of the equation. Okay. All right. So we can solve this simultaneously. We will do this question in the next chapter where we will be solving the simultaneous equations. For now, the only thing which you need to understand is how to play with such questions. Okay. So apparently this was an easy question, but this looked a bit tricky. But no, it wasn't. Just follow that 3 is the smallest number. Try writing 27 with 3. Try writing 81 with 3 as the base and something in the power. 81 cannot be calculated directly, so think about it with 9 and 9, and that way you would be able to do it. Okay. So anything that you have not understood in the first question?
No, it's clear. I wanted to ask if we would get any question in which the bases couldn't be made same in any way.
Okay, okay, okay. No, 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 no. That would be very, very difficult. No. Yes, that obviously, yes, that could be, but for that you won't be following this method, right? For that we will talk about logs. Do you know what logs are?
No.
Okay, then that's completely fine. Okay, when we will go to that chapter, then we'll talk about that. Okay, at your level, you won't be coming across such questions which cannot be, done directly. Okay, otherwise we use log. That's also easy, but no, not at all at your level. Okay,
Okay.
all right. So this was the first question. Let's talk about the next one. So let me just take it out. Okay. This is question number 2. In this question, again, we have 2 to the power x plus 1 divided by 2 to the power minus 3x equals 2x divided by 32. And the question is to solve this equation. Now, whenever you are solving something, you know that you need to find the value of the variable or the unknown. Okay. So every base is same except this 32. So step 1 would be to rewrite all this with same basis. Okay. We have just done this for 32. So that is why I wrote directly 2 to the power 5 is 32. Okay. Now we have same bases everywhere. So let's just try solving, simplifying the left side and then the right hand side. So if I talk about the left side, I have same bases and it is being divided. So what I can do is I can just subtract the powers. So 2x plus 1 minus the power in denominator equals, now let's simplify the right hand side, 2x minus the power in denominator, and finally I can write it as 2 x plus 1 minus into minus would be plus 3x equals 2 to the power x minus 5. Okay, now what do we see? We see that our bases are same and these two expressions are equal. This means that the powers are also equal. So I will just equate the powers. X plus 1 plus 3x equals x minus 5. This would be 4x plus 1. X plus x is 4x plus 1 equals x minus 5. So this would be 4x minus x equals minus 5 minus 1. And this is 3x equals minus 6. And x would be minus 6 by 3. And finally it would be minus 2. Right? So did you understand this, Turhan and Sunny?
Yes.
Okay. All right. Let's talk about another question. So we have a to the power 3 by 2, b to the power 5 by 4, whole power 4. It is being multiplied with a to the power minus 6 plus b to the power 3. And you have to simplify this. Okay. So let's do that. Now we see two expressions being multiplied to each other. Okay, so we can multiply them later on, but we need to simplify them first on their own. Okay, let's start off with the simplification of this one. So we have 4 outside the power. So basically we know that property where we had a into b with, let's say I'm making 4, but in the rule we had m. So that basically was a to the power m multiplied by b to the power m. Okay. So again, we have two numbers that are being multiplied. We have a common power that is being shared. So it would be a to the power 3 by 2 multiplied by 4 multiplied by b to the power 5 by 4 multiplied by 4. This is the first bracket, and the second one would come as it is because it's already simplified. We don't need to simplify it further. And 4 and 2 can be cancelled. This would give you a to the power 6. And this 4 and this 4 can be cancelled, and this will give you b to the power 5. Okay. Now, basically, we have number, a constant, an expression that is being multiplied to a sum. So this is very simple. We need to do it this way. First, we will multiply this whole thing with a to the power minus x. So that would be a to the power 6, b to the power 5, a to the power minus 6. Then plus sign will come, and then again we will multiply this whole thing with the second term. And this time it would be a to the power 6, b to the power 5, b to the power 3. Okay. Now let's just write down the same terms together. A and a are same. A to the power 6 multiplied by a to the power minus 6 multiplied by b to the power 5 plus a to the power 6, b to the power 5, b to the power 3. We know that when bases are same, powers can be added. A to the power 6 plus minus 6 multiplied by b to the power 5 plus a to the power 6. Again, same basis, so powers can be added. 5 plus 3. So this will give you a to the power 6 plus minus 6 would be 0 multiplied by b to the power 5 plus a to the power 6 multiplied by b to the power 8. And finally, a to the power 0 is what? Is it 0?
1.
Very good. So 1 into b to the 5 would be b to the 5 plus b to the 8, a to the power 6. Okay. This would be your answer. So did you understand this, Saneem and Turhan, both of you?
Yes, ma'am.
Okay, and what about you, Turhan? Turhan, did you understand this? Okay. So let's talk about another question. Let's say we have 2 into 16 power x minus 5 4 power x plus 2 equals 0. Now here basically we need to solve again, okay? But we cannot solve this directly. So yes, first, okay, and this is also an answer to Saneem's question, but this question is not exactly of that type, right? Here you need to find the value of x, yes, but in this case you won't be using logs, and in this case you cannot do it directly as well, because you cannot make every number like you have 5 here, so you cannot write 5 that way, okay? And this initially we were talking about some linear equations. You will see that this equation will turn out to be a quadratic equation, okay? So yes, you can say that you can get some questions where you cannot directly use that method, but in those cases the equation would not be linear. By that I mean, now look at this question. So it is 2. Can I write 16 as something with base 4, 4 square, and then whole power x, right? Minus 5, 4 to the power x plus 2 equals 0. This would become very easy, don't worry, okay? I can write it as 2, 4, and can I just write x inside and 2 outside? Because we know that 2 and x would be multiplied and order does not matter. Yes, Saneem, is this okay?
Yes.
Okay. All right. So this, okay. Now at this point, we will use a substitution. And this is why I was telling you that this is the quadratic equation. You can write it as u equals 4 to the power x. So it would be 2u square minus 5u plus 2 equals 0. Now you can easily find the value of u by using the middle term breaking thing. And once you have your value of 2, but once you have a value of u, you can just use that for finding out the value of x, okay? So how do we find the value of u? So you have to think of two numbers such that when you multiply them, you get 4, and when you add them, you get minus 5. Yes? So can you think of two factors? Hmm. Yes, you can think of two factors. Minus 4 and minus 1. When you will multiply them, you will get 4. When you will add them, you will get minus 5. Okay. So this would be 2u square minus 4u minus u plus 2 equals 0. I can take 2u common, u minus 2 minus 1 common, u minus 2 equals 0. Now my two factors are 2u minus 1, u minus 2 equals 0. And one factor, like one value of u is 1 by 2 and the other value of u is 2. Okay, I repeat. This was the question initially. This was the question. And you need to solve for x. Now the question is that how would you know if you can basically write it as power of 2 or the smallest base, and then just equate the powers. You would know that by looking at the nature of question. Okay, now as soon as we saw this question, we had this 5. Okay, we cannot write 5 as a power of 2, right? So this means that we need to do something different, and the biggest hint and the biggest clue is that in such type of questions, this number and this number would have a link. Okay, square of this number would basically be this number. So it could be that you had 36x minus 5, 6x plus 2, something of this type, right? Again, 6 square was 36. So this will tell you that this is your quadratic equation. Okay, so first you will write everything as this number, and once you write everything as this number, you just have to use a substitution, and once you have substituted, you clearly see your quadratic equation. Now it's your choice, you can solve it whatever way you want to. Okay, so we have solved the quadratic equation and we got two values of u. So let's use these values of u in order to find x. So u is 1 by 2. So we know that u equals 4 to the power x. So I can write it as 1 by 2 equals 4 to the power x. Again, this is the smallest number. I need to write down every number as a base of 2. So I will take this 2 to the numerator and it would become 2 to the power minus 1. This 4 can be written as 2 square and x is being multiplied. Again, 2 to the power minus 1 equals 2 to x. Bases are same. I can equate the powers. So this is giving me minus 1 by 2 as x. Similarly, you can use the other value of u, that is 2, and this will give you 2 equals 4x, 2 equals 2 square x, and then 1 equals 2x because I have compared the powers. And finally, this time I'm getting x equals 1 by 2, right? So these are the two values of x which you will get. So did you understand this?
Yes, I did, but I had to ask that in these type of questions, we always have to like involve you.
Yes, yes, yes. Because look. Otherwise, you would not be able to solve this, right? Otherwise, you see 5 here. When you have 5, you know that you cannot write it as base of 4 or 2. So you need to do something else, okay? And this is basically your hint. You need to convert this weird equation into a quadratic equation of this type, okay? And this you can say is the
The
most
basis of
difficult.
unknown will be
Sorry, say it again. Yes, Sunny. Okay. So basically, you can think about this as the most difficult type. Okay, this is the most difficult type. The question cannot be difficult than this question, and even this question is not difficult. Okay, but the only thing is, I told you the hint which you will be using. Once you know your hint, you're good to go. You will have your quadratic equation, and then you can easily find the values. Okay, Turhan and Saneem, did you understand this? I think there's some connectivity issue. Okay, let's wait for Saneem is back. Yes, Salim, can you hear me now? Let's wait for Salim. I'll just ask her. Yes, Sanim, can you hear me now?
Yes, sorry, I got disconnected.
Yeah, okay, no worries. So, what was your question?
I want to ask if the unknown, the base of the unknown will always be similar. Like we could take the same base.
Yes, otherwise, like if you are able to write every number with the same base, yes, surely you just need to compare the power, okay? But an issue could be that how are you going to write down zero then, right? How would you write down zero with the same base? We don't know how to write down zero. We know how to write down one. We did that example in which I wrote 1 equals 2 to the power 0, but we don't know how to write down 0, okay? So this 0 would be an issue every time,
Okay, got it.
okay? So that is how you will be basically doing it. And once you practice more questions, you would get a good idea about this, and you won't be able to find such questions because this is I already told you, or I think you got disconnected when I was telling to him that this is basically the most difficult type, right? So don't worry about this. This is also easy. You would be able to understand it if you are not able to do it that way. And it is highly likely that you come across that type in question, which we have already done, right? This is basically a very difficult question at your level, but it is a past paper question. Like it is basically a question from this topic from indices. So it's basically a blend of this topic and quadratic equations, right? So that is why it could be that you are finding it more difficult, right?
Okay.
Okay, so I'll clear the screen. Right. So that is it. This was basically the chapter of indices. Now we have to talk about the next chapter, in which we will see how to solve equations and inequalities. Okay, now when we have equations, it could be a simple equation with one variable, it could be two equations with two variables. We call them simultaneous equations, right? That is how it is. But we have been solving equations, so I will obviously teach that as well. But for now, I want to talk about inequalities, okay? And then we'll talk about equations. So let's talk about the next chapter, solving equations and inequalities. Okay. And here particularly we'll talk about inequalities. Okay. Now basically what is an inequality? We know that inequality has this sign, this sign, this sign, or this sign, right? Inequality is basically not equal. Okay. So we will solve those equations, and whenever we solve any inequality, we end up getting a range for the unknown variable. Okay. So let's talk about some linear inequalities. When I say linear inequalities, the power of x would be 1. So it is minus 3x plus 5 less than equal to minus 16. Now this is a simple equation. It's not an equation because we don't have the equality sign. We have inequality sign, so it is an inequality. Okay. In order to find the range, in order to solve this, we need to find the range of x. How do we do that? Again, by making x the subject. Okay, let's do it. So we have minus 3x less than equal to minus 16 minus 5. Minus 3x less than equal to minus 21. Now, what is the next step? Next step is to take this minus 3 to the other side of the inequality. Now remember, this is a rule. Whenever we take, not exactly take, whenever we divide by a negative number, reverse the inequality. So this basically means that right now we have this sign. When I will take minus 3 to the other side divided by minus 3, I will change the sign to this sign, okay? And this means that x is greater than equal to 7. Did you understand this?
Yes.
So if I talk about the range, it would be that x is equal to 7 as well as it's greater than 7. So it could be 8, 9, 1000, 1 billion, anything but greater than or equal to 7. Okay. This was the first question. Let's talk about another question. Again, this is going to be a linear inequality. We have 3, 5x minus 7 greater than equal to 54. Okay. Now again, we have to solve this inequality. In order to solve any inequality, how do we do it? By making x the subject. So let's, either you can just divide 3 on the other side or you can do it this way, okay? So we can multiply 3 with 5x and with 7. This will give you 15x minus 21 greater than equal to 54. I will take negative 21 to the other side. But since I'm adding it, so sign would not be changed, okay? So this would be 15x greater than equal to 54 plus 21. That would be 75, and x would be greater than equal to 75 divided by 15. Again, we are dividing something, but this something is positive, okay? So sign would not be changed and x would be greater than equal to 5. So again, if I draw the number line, if this is 0, 1, 2, 3, 4, 5, this is 5. The range is 5 and greater than 5. Okay, so it could be 6, 7, 8, 5.5, 1000, 1 million, anything but greater than equal to 5. Right. So these are some simple inequalities, right? Let's talk about some more. Let's say we have, and this is the last question for today. Let's say we have x minus 1 multiplied by x minus 5 less than 0. Okay, my first question is that is this a linear equation or is this a quadratic equation? Inequality or expression, whatever you call it. Like x minus 1 in, sorry,
Inequality.
yeah, it is unequal, okay, but is it linear or quadratic? Yes, very good, Turhan, but is it linear? Quadratic, right? Actually, I'm not able to hear you properly, so but I think you said it's
Yes, quadratic.
very well done, excellent. Okay, why? Because we know that when we will expand this, we will get x square, and that is basically our hint. Okay. Now, whenever you come across such questions, basically, if it was an equation, we would have said that x minus 1 equals 0 or x minus 5 equals 0, right? But this is an inequality. And what is the inequality saying? It is saying that when we are multiplying these two numbers, either when we are multiplying these two numbers, we are getting this less than 0. So this is negative. So this means that one of the two factors would be positive, one would be negative, and we cannot think about it this way. So this is how we do it. So basically for this, you need to know the plotting. Do you know how to plot a quadratic equation? Turan and Sunny?
On a graph?
Yes.
Not really.
Okay, that's fine. That's fine. Okay. So think about it. X minus 1, x minus 5 equals 0. What would be your answers? Your answers would be x equals 1 and x equals 5, right? This means that y and x. That when the value of y or when the value of function is 0, your x is 1 or your x is 5. So this means that if this is 1 and this is 5, these would be the 2 points, right? Now I'll tell you, whenever we talk about quadratic equations, you will always get a fixed shape. Either it would be of this type or it would be of this type. That is it. Okay, that is it. And you will get this type when your coefficient of x square is positive, and you will get this type when coefficient of x square is negative. For example, in our case, when we will multiply x with x, we will get x square. So we know that this would be the shape, and this graph would be passing through this point and this point. So it would be something of this type, right? It's a rough graph. It's a rough graph. We are just plotting that for a concept. I repeat, this was your question. You need to find the range of x satisfying this inequality. Okay, I told you for quadratic, you cannot think about it the way we think about it for equations. This basically claims that the product of these two factors is negative, which means that one of them would be positive and one of them would be negative. So we cannot think about our answer directly. What we need to do is, since if we solve this, we will get x equals 1 and x equals 5. So we will make a graph with 1 and 5. And since the coefficient of x square is a positive number, that is positive 1, it would be a this shaped graph, okay, a U-shaped graph. And now what is the claim? The claim is you need to find the value of x when it is less than 0. This is basically your y, okay? So when y is, sorry, when yes, when y is greater than this. Okay. So this means that your range is going to be, let me disrupt all this. Okay, think about it this way and then you will get a better understanding. Okay, this was the question. Write it down this way. Y equals x minus 1, x minus 5. Okay, less than 0. This means that when y is less than 0. When is y less than 0? This is 0. These are the points of the graph when your y is less than 0. Okay. This means that these points are basically the points which we are following, and we are interested in the x coordinates of these points. So what would be the x coordinate of this yellow point? 1.1. What would be this one? It would be 1.5. This one, 2. Okay, something of this type. So all these points are between 1 and 5. So your answer would be x greater than 1, less than 5. Okay. I will explain this again. Wait. Let's say that your question was the same but with the opposite sign. Okay, this time the sign was different. Again, we are solving inequalities. In order to solve inequalities, we did it for, yeah, this would be the sign. Okay, again, x into x would be positive x square. We know that it would be a u passing from x equals 1 and x equals 5. Okay, this is 1, this is 5. Again, the same type of a graph, something of this type. Okay, what is the range? Your range is that this is greater than 0. This means that y is greater than 0. This is 0, this is y. So y greater than 0, I'll just highlight the points on the graph where y is greater than 0. So these are the points. Okay, now basically they are corresponding to this value of x, 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 this value of x. So what do we know? We see that for all the values of x less than 1 and for all the values of x greater than 5, our inequality is being satisfied. So for x less than 1 or for x greater than 5, our inequality is satisfied. So this would be the answer. Okay. Either you can just learn it directly, but I would never ever advise you to learn it this way. It's always better to plot the graph and then do it. Okay. Because it could be that you had minus x square here. In case of minus x square, we have different things about which we'll talk about tomorrow. Okay. So did you understand this much, Turhan and Saneem?
Yes, I did.
Okay. And what about you, Turhan?
Yes, ma'am.
All right, all right.